All right, let's do part C, which is to implement make checker tree, which takes in some tree containing digits as its labels, and returns a tree with functions as labels. When applied to another tree, the function tree mutates it so that each label is true if the label is a combo of the number formed by concatenating the labels from the root to the corresponding node of t. That is a mouthful, but let's look at the doc tests. So we initially have some t1 with 5, 2, and 1. That's this tree that I've drawn on the right. And we get the function tree from it, which I've indicated by calling fn. And finally, when we apply this function tree onto some tree t2, we get true, true, and false. So we get true, true, and false. The way we get that is, for the first one, we check if 5 is a combination of 5. That's true. For the second one, we check if 10 is a combination of 52. The way we got 52 is we took every number from the root to this node and concatenated it. So 5 put next to 2. If it was longer, then we'd have, like, say, 5, 2, 3. Just like that. And then finally, we checked if 7 is a combination of 51. It's not, so that's false. So how can we do this? Well, we first have to, we just have to make this tree, and they've made it for us, actually. It's a new tree that takes a function and branches. So the function is the label of the root node, and branches are trees that contain more functions. We can first figure out how to just come up with this function by reading what it's supposed to do. What the function is supposed to do is return true if the label is a combination of the path in t from the root to its corresponding node. And this function takes in some input. Namely, it's going to take in, say, like this 10 to see if 10 is a combination of 52. So this function is going to be a one-argument function that takes in some argument k, and it's going to return true if is combo of some number and k returns true. Well, what's that number? That number in the very simple case is just going to be 5, which is the label of the tree, because this is the root. So how we get that is just by using t.label. Let me make some more space. But usually it's not just going to be t.label, right? It could be 52, it could be 523, 524, and so on. And we don't actually know, really, anything except for the root label. So for example, if we were trying to get this 523, we only really know of this 3 unless we have some other variable to keep track of this 2 and this 5. And in fact, we do. We have this variable so far that's initialized to 0. So this so far, how we can use it is the so far can be 52, so our number so far, and then we have to combine it with 3 to get 523. Well, that should be easy enough. We just multiply 52 by 10 to get 520 and add 3 to it to get 523. So what we're really doing here is taking so far, multiplying it by 10, and adding t.label. And that becomes our new so far, which we can use when we make these branches. So yeah, after we've come up with the label of this tree, just like in the previous problem, we want to apply this function onto each of the branches. So we're done, we've gotten the function for 5, and we also want to get it for the rest of this left subtree, and the rest of this right subtree. Well, that just means we have to make a recursive call. And branches is supposed to be a list, so we can use a list comprehension here since we're only given one line. And it's going to contain, each element of that list is going to be a call to make checkered tree, because it's going to make a tree for that subtree with that branch and some value for so far for each of the branches in this tree. Now, what's this variable in here? Well, that could be like our new so far, because so far starts at 0, but then next time when we call it on this, for example, left subtree, we want so far to be 5 so that it can be combined with 2 to get 52. So far is just what so far used to be plus the label. So for example, if we were at 2, so far would then become 52 the next time. And we already have a way to do that. It's just going to be so far times 10 plus the label. And they actually gave us a variable here to keep track of that. So we can just use this variable. Great. That's pretty much it for this question. Once again, what we did was we first figured out what our label should be, so this fn, and then we just recursively called our function on each of our branches. And that's exactly how we did the previous problem. We figured out what the label should be, and we recursively called on each of our branches. That's about it. Feel free to leave any comments or questions on Piazza.